Have you ever encountered a number that makes all familiar logic suddenly feel meaningless? In a brief, fleeting moment, we are faced with a figure about the universe that is not just massive. It is strong enough to shake our understanding of time, space, and reality itself. It is a number regarding how we understand the very fabric of the cosmos. For a long time, humanity has obsessed over the scale of our existence. We look up at the night sky and try to comprehend the distances between the stars. But when we actually measure it, the math seems to contradict our fundamental intuition. Our universe is roughly 13.8 billion years old. This is a proven number, verified by the most accurate cosmological observations available to science today. But here is the strange reality. The part of the universe that we can observe is 93 billion light-years across. Pause for a moment and think about that. If light is the fastest thing in existence, moving at the absolute speed limit of reality, how can we possibly see things that lie at a distance far beyond the age of the universe itself? If the universe is only 13.8 billion years old, shouldn't the absolute maximum distance we can see be 13.8 billion light-years in any direction? It sounds like a fundamental mistake. It sounds like a misinterpretation of how we measure this vast expanse. But the truth is, this 93 billion light-year figure is perfectly accurate. It is built upon extremely reliable scientific data. The error is not in the numbers. The error is in our intuition regarding how space actually works. Because in the universe, distance is not a static thing. To understand this paradox, we need to start with a simple truth that is completely backwards to everyday human intuition. The space where everything exists does not stand still. In our daily lives, we think of space as a static stage, an empty, unmoving box where objects simply exist and move around. But space is something that can change. It can stretch, bend, and even deform over time. There is an invisible mechanism constantly at work, determining the entire evolution of the cosmos. Expansion. Imagine drawing little dots on the surface of an uninflated balloon. When you start to blow air into it, the balloon expands. The distance between all those dots is increasing, even if the dots themselves are not moving across the rubber. No single dot is the center, and there is no real point that everything is flying away from. What is happening is that the surface of the balloon itself is expanding, bringing everything along with it. Our universe works in exactly the same way, but in 3 dimensions instead of 2. Galaxies are not flying outward through space like shrapnel from an explosion. It is the space between the galaxies that is getting more and more stretched. This makes all the galaxies appear to be moving apart, even though there is no direct physical force pushing them away from each other. And here is the most crucial part. The entire universe is quietly accelerating this process over time. The further away a galaxy is, the faster the speed of separation. This is the first key to unlocking our paradox. Because of this constant expansion, distance in the universe is not as simple as we think. As light moves through the expanding space, its journey is no longer a simple, straight line through a fixed void. As the light travels toward us, the distance it has to cover is constantly changing. The path is being stretched underneath it. This makes the actual distance the light has to travel much longer compared to what we might first imagine. And that is when human intuition usually falls short. In the universe, it is not just objects that move. Space itself is part of that movement. But if space is actually expanding, there must be a trace, right? There must be proof that we can observe from Earth. That evidence comes from the light, the ancient messengers that bring information over billions of years from distant galaxies. When scientists observe light from these distant realms, they realize something very strange. The color of that light is not quite the same as what we measure in our laboratories. It is shifted slightly toward the red end of the spectrum, as if the light wave itself has been physically stretched out in the process of moving through space. This phenomenon is called redshift. It is one of the most important keys to modern astronomy. The special thing about redshift is that the further away a galaxy is, the more its light has been stretched. This shows that distant galaxies are leaving us faster than nearby galaxies. From this, a simple but extremely powerful rule was discovered. The greater the distance, the faster the separation. This is Hubble's law. It is one of the most important platforms to help us measure the size of the universe. Without even leaving Earth, we can infer that the entire universe is extending, all just by analyzing light. Light doesn't just tell us where an object is, it reveals how the universe has changed throughout that entire journey. Each ray of light is like an ancient message, recording the expansion of the universe over billions of years. When we put all this data together, a giant picture emerges. But there is still an important piece missing, a more ancient trace that helps us understand the exact age of the universe. It is a kind of light that has existed since almost the first moment of creation, and it still echoes to this day. Let us go back in time. Long before there were stars, long before the first galaxy ever formed, the universe was a hot, dense, blindingly bright place. It was so incredibly dense that you couldn't see through it. Light could not move freely because it was constantly crashing into a thick soup of subatomic particles. But as the universe expanded, it cooled. And then, a very special moment happened that changed everything forever. The universe became transparent. Light was released for the first time to begin a journey through the cosmos, no longer held back by the dense fog. That light still exists today. It acts as an ancient trace of a cosmic time just formed. We call it the cosmic microwave background radiation, a remnant left over from the very beginning. What is amazing is that this light comes from all directions simultaneously. It doesn't come from a specific point. It emanates from all of space, serving as a fingerprint across the entire universe. When scientists measure this background radiation, they are measuring the oldest light we can possibly see. It tells us precisely how long the universe has been around and how it evolved from its earliest state. From very small fluctuations in this radiation, we can deduce the giant structure of the universe we see today, the massive galaxy clusters, and the vast, empty voids. More importantly, it confirms the age of the universe with extremely high precision, roughly 13.8 billion years. This is not just a wild estimate. It is the result of overwhelming, independent scientific evidence. From this ancient light, we know exactly when the universe became transparent. And from there, the light began a journey spanning billions of years to reach our telescopes today. But remember our first principle. Throughout that journey, the space the light passed through changed drastically. This causes the current distance of the object to be completely different from its original distance when the light was first emitted. This difference is what leads us to our final solution, the 93 billion light years. When you look up at the night sky, you are not just looking at space. You are looking back into the past. Light takes time to move. When you look at the sun, you see it as it was 8 minutes ago. And when you look at distant galaxies, you are seeing them as they were billions of years ago. Looking further out means looking deeper into the past. But light does not move in a stationary universe. While the light was traveling toward us, the space between us and that distant galaxy continued to expand. When the light was first emitted, that galaxy was much, much closer to us than it is now. But as the space stretched, the physical distance between us and that galaxy grew immensely. So, when we measure distances today, we are measuring the current position of the galaxy, not its original location. This is the point that goes against our usual intuition. We are seeing light from the past, but we are calculating the distance in the present. These two systems are not the same. The light tells us how long it has been traveling, say 13.8 billion years. But it doesn't say what the current distance is. Because space has continued to expand all that time, the actual distance today is much larger. This leads to an important concept in cosmology, comoving distance. This measurement reflects our current position in the expanding universe, accounting for the stretching of space. When you apply that measurement, the radius of the observable universe comes out to about 46.5 billion light-years. When you double that number to get the diameter across the whole sky, you get 93 billion light-years. It is a number that is not contradictory. It simply reflects a universe that is actively working, stretching, and evolving. The paradox fades away, making room for a much clearer, yet vastly more terrifying picture. Now that the figure of 93 billion light-years is no longer absurd, a bigger question remains. Is what we see the entire universe? Or is it just a very small part? If you shrink the Earth to a speck of dust, the entire visible universe is still beyond all comparison to anything human minds can grasp. Yet, every light we see is just a tiny part of a giant structure. Everything we can observe is strictly limited by the speed of light and the duration the universe has existed. This means the 93 billion light-year sphere is only a description of what we are physically allowed to see. There is almost certainly more out there. There are regions of space that are so far away that their light hasn't had enough time to reach us. And worse, there are regions whose light may never reach us. If space continues to expand faster than light can travel through it, the light from those distant realms will never bridge the gap. This makes the universe a place where there are always areas beyond observation. We are living inside an observation bubble. Outside that bubble, there could be a universe many, many times larger. This realization is magical, yet humbling. It forces humanity to recognize its own limits in understanding the entirety of reality. No matter how far science advances or how powerful our telescopes become, there are always areas we cannot reach. It makes the cosmos not just large, but fundamentally mysterious, forever beyond all cognitive limits. This creates a special boundary. It is not a physical wall in space. It is the natural limit of our ability to see, known as the cosmic horizon. Out at that boundary, nothing special is happening physically. There is no wall, no end. There is simply a lack of information. Our bubble is not fixed, either. It changes over time. Because the expansion of the universe is accelerating, some areas that were once visible are slowly disappearing. Their light can no longer keep up with the stretching of space. The universe is not just vast, it is slipping away from us, with what we can see constantly fluctuating over time. Act 6, the center of nowhere. Pacing, uplifting, existential. Visuals of humanity, Earth, and zooming out into the cosmic web. Voiceover. When trying to comprehend this scale, a natural question arises. Where are we in all of this? Humans often like to think we are in a special place, a certain center of this grand structure we are observing. But the reality is completely different. The universe has no center, and it doesn't have any points that are objectively more special than the rest. No matter where you are in the universe, whether you are on Earth or in a galaxy 10 billion light-years away, you will see all the other galaxies moving away from you. It will always look as if you are standing at the exact center of the entire universe. This does not mean you are special. It merely reflects the way space expands evenly in all directions, prioritizing no single location. There is no center, and there is no clear edge. There is only a space that is expanding, where every point plays the exact same role. This makes our position incredibly normal. We are not the center of any grand architectural structure, but at the same time, our position is special in a way that is hard to express. It is special because, from this random, floating rock, we have the capacity to observe and understand a significant portion of the cosmos. It is a rare privilege that allows a small, fragile organism to perceive the vast scale of reality around it. The deeper we understand cosmology, the more we realize that our physical location is not nearly as important as the perspective we hold. We possess a perspective that allows us to look into the deep past, measure the present, and deduce the terrifying, accelerating future of the universe. We are just a small observation point in a system much larger than ourselves. Yet, we are small enough to ask the biggest questions about the nature of space, time, and our own existence. Perhaps what is important is not where we are, but who we are. How much can we understand about the place we inhabit? Because even though our physical footprint is practically zero, our cognitive abilities can extend across 93 billion light-years of stretching space. That alone makes us a special part of the universe. A small part, but one able to see far, understand deeply, and question the whole of reality. The universe is forever beyond our ability to fully conquer or completely observe. It is a place where every answer merely opens up more questions, driving us deeper into the nature of existence. And perhaps the most important question is not how wide the universe actually is. It is how much we can understand about it before our time is up. Every step of understanding brings us closer, even if we can never reach the ultimate limit. That journey, the pursuit of the unreachable, is what makes space exploration so profoundly meaningful to humanity. If there is one question left behind after all the math and physics, it is not about a number. It is about what exists outside of that number. What exists beyond the edge of the visible universe? And will we ever be able to accept that we might never know?